That's covered the graphs. We've had a look at equations, rearranging and solving, and now we're going to look at Pythagoras. So calculate x in both of these questions. Okay, so the first thing to think about for Pythagoras is Pythagoras works for right angle triangles. If you've ever seen The Wizard of Oz, the scarecrow says at the very end the Pythagoras theorem absolutely incorrectly, which is quite a funny watch if you want to go onto YouTube and do that. Almost every single word of it's wrong. But the correct way to word it is to say the sum of the squares of the shorter side are equal to the square of the longer side for a right angle triangle. So if I square this side and I add it to the square of this side, it will equal the square of this side. And graphically, I think that's quite beautiful. It looks like this. Okay, so if that's x long and this is x long, this would be x squared. If that's 8 long, this would be 8 long, so this would be 64. And then 17. And 17, squaring 17 is a little bit tricky, so I always visualise this. I always say that's the same as 10 and 7 times 10 and 7. So that's 100, 70, 70 and 49. Add those numbers together. So that's 100, that's 240 plus the 49. So that's equal to 280. So if you're trying to do these, you can do them in your head quite quick. So that's going to be 289. So what this is saying is x squared plus 64 is equal to 289. And it'll be the same for the other one. So if you're thinking of Pythagoras, try and think of what's going on. This side squared plus this side squared equals this side squared. Now how did I know it's not this side plus this side squared equals this side? Well, that's because the 17 is the longest side. It's the sum of the square of the shorter sides gives me the longest side. And the longest side is always opposite the right angle. See the two shorter sides touch the right angle, but the longest side does not touch the right angle. So that's our hypotenuse. Okay? And probably the hardest bit of Pythagoras is spelling Pythagoras and hypotenuse. So yeah, the rest of it's quite straightforward. In both these questions, you can see we're trying to calculate a shorter side. So we know the hypotenuse. So in that case, we're going to be doing what's called a Pythagoras takeaway. We're going to do c squared take away b squared is equal to a squared, because for Pythagoras we usually call the short sides a and b, and the long sides c. So I'm going to call that c, b, and a, and on this side I would call that c, b, and a. But you don't have to really worry about that too much. It's Pythagoras takeaway. Okay? You're just saying 17 squared take away 8 squared is equal to, in this case we're calling it x squared, and over on this question we're saying that 7.5 squared take away 4.5 squared is equal to x squared. So it's just Pythagoras takeaway. Don't you have to worry too much about the algebra if you want to. If you're trying to find the longer side, so say we never knew this and this was something like 5, it would be Pythagoras at 4.5 squared plus the 5 squared equals x squared. So instead of take away, we would have add. So actually, just to be, consistent, I'm just going to take away the algebra just to kind of show you how simple this working is. So it's the big one squared take away a small one squared equals the other small side squared. You need your calculator for these questions. So I'll do the first one. So 17 squared, just said was 289. And again, I would really implore you to get used to your calculator and pick the same one. Try not to use the apps, don't use the apps that are built in. Use a scientific app. So 17 squared, take away 8 squared, it's going to give me 225. But yeah, try and get used to your calculator, where all the buttons are, and don't use the apps, they're not just as good. And at the same time, I'll work my way through this question. And the only hard bit here now is we need to get x on its own. So how do I get x on its own? The opposite of squared is square root. So what I'm going to do is square root both sides. So I square root that just becomes x. And the square root of 225, I can do that on my calculator, square root of 225 is equal to 15. And all that's saying is, the square root means what times what gives me 225. That's all that's saying. So 15 times 15 gives me 225. So this side in here would be 15. I can then check I've done the question right. I can do 15 squared plus 8 squared and make sure that adds up to 17 squared. Let's do the other side now. So 7.5 squared take away 4.5 squared is going to be 36. And 36 is equal to x squared. So I'm going to take the square root of both sides. You can do that on your calculator if you want. So x is equal to the square root of 36. So what times what gives me 36? Well, the answer is 6. And that's in meters. So try and get used to thinking about your square numbers as well, because they pop up quite a lot. These are nice little, what's called Pythagorean triples. Nice little numbers that they give you whole numbers and not crazy decimals. But yeah, try and think of your square numbers. 2 squared is 4. So that means that the square root of 4 is equal to 2. 3 squared is equal to 9. So that means that the square of 9 is equal to 3, because it's saying what times what gives me 9. So try and get used to thinking about those numbers as well. But yeah, that's a bit of Pythagoras. Here we go. So this question here, let's try this one. There's my right angle. So these are my 2 shorter sides. Opposite the right angle is the hypotenuse. So that's obviously the longest side. So therefore, I'm going to do a Pythagoras add. Now, looking at the numbers here, they don't quite make sense, do they? These are probably round the other way. But because one of the things I was going to say is make sure you do a sense check on your numbers. If you do a Pythagoras, if you know that's the longest side, and you work out an answer which is bigger than that, chances are you made a mistake somewhere. If you get a number bigger than 17, you get a problem. So we get 6 in here, that makes sense, and we get 15 in here, that makes sense. These numbers don't look quite right, but our largest number should still be bigger than these two. So we're trying to find out the longest side, so it's just going to be a Pythagoras add 7 squared is equal to x squared. This one here, let's start us off. There's our short side and there's our long side. So we know the long side, this one's going to be a Pythagoras takeaway. So I won't do that one, the takeaway is just the same as those. But just to remember, your first step is identifying the hypotenuse, or the longest side, and then deciding if it's add or takeaway. So 6.2 squared plus 4.7 squared, and that gives me 60.53. And I want to get x on its own, so then I need to square root both sides. So I'm going to square root 60.53, and that gives me 7.78. And all that's saying is 7.78 times 7.78 gives me 60.53. Close enough, I've just rounded that off. And our units are centimetres. So nice and easy, nice and easy. Last bit of Pythagoras. The only way we can make it complicated is to put it onto a graph. Now all this graph is saying, calculate the length, it's telling you that each of these boxes is 1, okay, because that's our scale, isn't it? 0 to 1. 0 to 1, 2, 3. So each of these boxes is 1 in length and 1 tall. So we actually then don't know what a diagonal distance is, do we? We know that that's 1, we know that's 1, but we don't know this diagonal distance. We would have to use Pythagoras to work it out. So all we want to do, first of all, is make a nice little triangle. So I'm going to extend this line over, and I'm going to extend this line down, and see where they meet. They meet at the right angle. So I can just rub these bits out, don't need these. There's my little triangle. And I can just count the boxes now. I can see that's 2 boxes along, and this is 4 boxes high. So how long is this length going to be? Well, the hypotenuse is the longest length, the diagonal. So I'm going to use a Pythagoras add to work it out. So I'm saying that x squared is equal to 2 squared plus 4 squared. And can I just point out, it doesn't matter if you've got x squared on that side or it's exactly the same. Always, it's good to finish off with the x on the left, but you can start your equation this way or start it this way. It doesn't really matter. So in this case, x squared is equal to 4 plus 16, so that's 20. So in the square root of 20, you can do that on your calculator. But again, all we're doing on the calculator is saying what times what is going to give me 20. So the square root of both sides, it's going to give me 4 point, and I'll just round that off to 2 decimal places, 47. I think in this case I would say units or squares or something like that, okay? It's 4.47 units. If that's 1 unit along and 1 unit up, this is 4.47. Fantastic. So that's a wee bit of recap of Pythagoras. So next we're going to move on to scales and reductions.